test for the qualifications, what's the first thing it tells you? What's the first line? Can someone explain, just explain what the first line means? What does the first line mean?
That the things have to get bigger. The terms have to get bigger than each other. One sequence is bigger than 0.
So it says, suppose that A and B for all values of a certain value. Okay. Suppose AN is less than BN for all. Okay, if BN converges, then AN converges. If AN converges, then BN converges. Explain why the comparison test cannot be used to decide if the series of 44 to 45 converge. So what type of series is 44? Alternating. Something negative. No matter how far you go, there's always going to be at least an infinite number of negative numbers after that point. So the comparison test only works when the sequence gets to a point eventually where it stays positive. Where it stays positive. Does this thing stay positive? No, it doesn't. It never gets to a point where it stays positive. It becomes, never gets to a point where it stays positive. Does that make sense, everybody? Explain why the alternating series test cannot be used to determine if the series in 48 to 50 converge or diverge. So you have, is this an alternating series?
Yes.
It is. It is. That's nice. Converges if, what does it say here? Every next term has to be smaller than the one before it. Every next term has to be smaller than the one before it. Does everybody see that right there? So let's look at this series here. What does this series do? What's the first term? Plug in 1. What do you get? What do you get? 1. Plug in 2. What do you get? -2. What's the next one you get? What do you get next? 3. Then what? 4. And then 5. And then -6. Here's the thing. For you to apply the alternating series test, every single next term has to be smaller than the one before it. Is that true here? Yeah, sure. -2 is less than -1, but then what happens? It gets bigger, smaller, bigger, smaller, bigger, smaller. Does that make sense? The shape, do you remember the shape I drew for you for when the alternating series test applies? Do you remember what that shape looked like?
Yeah,
it goes like this, right? You have to have this general trend right here. It has to be filtering down. Is that what this is doing right here? It's similar, actually. What's it doing instead? It's going out. It's getting like really not going to converge. Well, the test can't be used. Magic number time. X equals 0. Look what happens. You end up with 3 equals a times x plus 2 times x minus 1. And I'll plug in the 0, so sorry. 2 times -1 plus 0 plus 0. Nice. So what does that tell you a equals? Hey, look at that. We found a. Nice. What's another nice number we could plug in? What's another nice number we could? Yeah. X equals 1. And then you get 5 is equal to 0 plus c times 1 times 3. So what does c equal? C equals what? 5/3. Nice. Keep going here. What's another nice number we could plug in? There's one more. -2. So you plug in -2 and you end up with -1 is equal to 0 plus b times -2 times -3 plus 0, right? So what does that tell you b equals? 1/6. Now, do you understand theoretically the algebra we just did, right? Can anybody now tell me, I know this is the big deep question, or maybe you can help me solve. I've yet to get anybody to help me with this because it's a problem, even though it works. This works every time I've ever done it. But just because this works every time I've ever done it doesn't mean it's necessarily 100% the proper maneuver. Here's the thing. Look at the original function. Do you see this original thing right here? What's the domain of this thing? You can't equal any of those things that we plugged in, right? It's x such that x can't equal 0, -2, or 1. They're technically not part of the domain, yet we're using them by plugging them in to get nice numbers. Does everybody see that problem? Now, this has been one of those things.
Partial integrals.
We can do the indefinite, what do they call indefinite integral, right?
Sure.
Is that when they don't have limits, right? Indefinite? Help me out here. Indefinite, right, thank you. Don't make me doubt myself here. What are you doing? So you have -3/2 over x dx plus, what's b here? 1/6?
Yeah.
1/6 over x plus 2 dx plus the integral of 5/3 over what? X minus 1 dx. And can you factor out all those constants to the front?
Yes.
Yes, you can factor out all those constants to the front. So what are you going to be left with? You have negative 3/2 integral of 1 over x dx plus 1/6 integral of 1.
It should be a negative 1 over 6.
Negative 1 over 6?
Yeah, because I think you get.
Yeah.
No, it's negative. Oh, yeah, it is because it cancels out on the right but not the left. Yes, you're absolutely right. Thank you. Negative 1 over x plus 2 dx plus 5/3 1 over x minus 1 dx. Now, are those decently straightforward integrals? Mm-hmm. Yeah, so you have negative 3/2 ln of what? Oh, look at that. Minus what? Minus ln of what?
Wouldn't it be 1/6?
Oh, there's a 1/6 in front, thank you. Minus 1/6 ln absolute value of x plus 2 plus 5/3 absolute value, not absolute value of, ln of absolute value of x minus 1 plus what?
C.
Yay, exciting. Cool? When you see nicely factored denominator, you need to think PFD, not partial, what was it? Portable flotation device? It's a, funny, partial fraction decomposition. That you will see at almost every level you take, combinatorial math, number theory, further calculus, linear algebra. The most amazing steps you will see, the nice way, that's the midpoint of this test. The nice way of saying it is pulling it out of thin air. That's the nice way of saying it. The not nice way of saying it is, would be the alternating harmonic. And what would be absolutely convergent? Negative 1 to the n over n squared. That would be absolutely convergent. The way you find, if you ever have to build an absolutely convergent series, just pick a series that's always positive that converges, and then add negative 1 to the n to the outside.
Or just use that, or just use the series that's always positive that converges.
Yes.
The absolute value of itself.
Yes. Oh, the absolute value of it's correct. That's actually, I like that. When do the hands touch each other? In the middle, always. Yes, that's actually really good. I like that. That's good. That's fantastically intelligent. I like that. Okay, so here's the thing. It just takes practice. You have to practice, practice, practice. We have lots of ways right now that, because it's the first time through for some of you, it's really hard to remember when to use which tests. We have, like, how do you know if a geometric series converges?
Terms go to 0.
If the terms go to 0 and the common ratio is less than 1. So we have we know how to do geometric series. We have a comparison test, we have a limit comparison test, we have an integral test, we have an alternating series theorem that tells us when an alternating series converges.
Can we get a list of these?
It's all in your book, it's in blue boxes.
Blue boxes.
Blue boxes, look at the blue boxes. So it just like factoring, it just takes practice, practice, practice. So what I'd like you to do right now, 9.4, 30 through 63, multiples of 3. I put these